Save, extinguish, rescue. If it gets hot for firefighters and the ambient air at the site doesn't allow for normal breathing, it has to be fast. Then what supports the emergency services? An advanced, self-contained breathing system, the compressed air breathing apparatus. Dräger is one of the world's leading manufacturers in the field of heavy-duty breathing protection. These compressed air breathing apparatuses are manufactured in Blyth, England, about 25 kilometers north of Newcastle upon Tyne. Several hundred people work there in the development and production of various components for the three series, PSS 3000, PSS 5000, and PSS 7000. One of Dräger's most experienced employees in Blyth is David Hodson.
The important thing with compressed air breathing apparatus is to make sure that the user always has air. Whether it's a 3000, 5000 or 7000, Dräger uses the same pneumatics equipment for them all. It's a case of saying if you had a car engine, you always want the engine to work.
The regulator is the engine, and thus the heart of every compressed air breathing apparatus. It sits directly on the oxygen cylinder and reduces the pressure of the air, which is compressed in the cylinder at 300 bar. In conjunction with the lung demand valve, it returns the breathing air back to a normal level. What makes the development and production of the pressure reducer a giant task is the environment, which varies between freezing cold and sweltering heat.
Firefighters typically these days can get up to temperatures of 200 degrees, 250 degrees C during the firefighting operations. In the first stage pressure reducer, temperatures can get down as low as minus 80 degrees C inside the reducer itself. This makes some real challenges for our design engineers and for the capability of our products.
Because moving parts are in the pressure reducer, just minimal tolerances are allowed in the production. Therefore, in Blyth, a computer-controlled automated production process was designed to meet the stringent requirements. Continuous quality monitoring and random measurements ensure that the pressure reducer works reliably for years.
This is the 5th generation reducer, and over the years I've seen many improvements. It works at extremely low temperatures and extremely high temperatures. You've got a second man attachment, so if you was stuck and there was an emergency where the fireman was in trouble, you could plug in the second man attachment and you could work off another fireman's breathing equipment.
The compressed air cylinder represents a similarly sophisticated product that provides the firefighter with air to breathe. To make it as simple and robust as possible, modern materials such as fiberglass and carbon are used.
The current cylinders are 50% lighter than the old steel cylinders. Its average is about 360 metres of fibre that's on each cylinder. The cylinder will hold 300 bar, but we test it up to 450 to make sure that the pressures that it's supposed to be worked with, we've got a good factor of safety.
With the so-called burst test, it becomes clear that the cylinder can withstand much greater pressures. More than 1200 bar of pressure are necessary to make them burst. In general, one does not treat the other components of the compressed air breathing apparatus gently. The goal is to find out if they are able to survive the harsh reality of operations.
We have an R&D test department here. They have various test chambers, various test equipment, which can do low temperatures, high temperature tests. There are flame tests done, there are flame engulfment tests done at 1000 degrees C, mechanical performance tests, tensile compression testing, and life cycle testing.
Every component passes through this process, leading to an overall system that is perfectly matched and ensures maximum reliability. So it is and remains. Every compressed air breathing apparatus that is sent out into the world from Blyth is through and through a Dräger quality product.